Hello everyone, I'm Chandrika from containing roll number 620138, and today I will be explaining about Fibonacci method of optimization in Python. So firstly, the Fibonacci method of optimization is an iterative algorithm, and it is used to find the minimum or maximum value of a function within a given interval. The Fibonacci method, the search interval is divided into two subintervals in such a way that the ratio of the smaller interval to the larger interval is equal to the golden ratio. Now here we have the algorithm. So first we take n value which is nearer to the given intervals, and then we calculate fn, which is the nth Fibonacci number, and it can be found by the formula fn is equal to fn minus 1 plus fn minus 2, and we calculate f0, f1, f2, and until fn, and which we are given lower bound a and an upper bound b, and we set l is equal to b minus a, and we set the desired number of function evaluation to be n, and we set k is equal to 2 initially. So in the first iteration we set k is equal to 2, then we compute lk star using the formula, and then we get new interval x1 is equal to a plus lk star and x2 is equal to b minus lk star, and then we compute f of x1 and f of x2, and then we use the fundamental region elimination rule to eliminate a region, and we set a new a and a new b, and we continue this iterations until k is equal to n, and if and if k is equal to n, we terminate it, and if not, we set k is equal to k plus 1 and follow the repeat the iterations till step 2. So in this case I have, or in this slide I have recorded why we take the k value to be equal to 2, because it helps achieve a good balance between number of function evaluations and the level of accuracy. If k is too small, the method may converge very slowly, and large number of iterations may be required to achieve the desired level of accuracy and the desired interval in which our maximum or minimum value lies. And similarly, when k is too large, the region may converge very fastly, and we will require lesser number of iterations, and the value of the minimum will be not quite accurate. So k is equal to 2 initially, taking that provides a good balance between number of function evaluations and the level of accuracy, since dividing the interval into two subintervals ensures that method always reduces the size of the interval by at least half in each iteration, which leads to optimum convergence. In some cases, larger value of k may be more appropriate, while in other cases, a smaller value of k might be sufficient. Next, here I have taken example in one variable. So we have taken f of x is equal to x square plus 54 by x in 0 comma 5, and we have taken n is equal to 3. So in first iteration we calculate f1, f0, f2, f1, f2 and f3. Here the upper bound is 5 and lower bound is 0. So we get L is equal to 5 minus 0, which is 5. And then we calculate L star. Here calculating L star, I've calculated L star as 2. So for x1 is equal to a plus L star, which is 2, and x2 is equal to b minus L star, which is, so here we got x1 is equal to a plus L star, which is 0 plus 2, 2, which is the new lower bound, and x2 which is equal to b minus L, which is the new upper bound. So we have got the new upper bound as 3 and the lower bound as 2, and then we calculate f of x1 and we calculate f of x2, if and x1 is less than x2 and f of x1 is greater than f of x2. So this by using the primary as I've told, by using the primary line algorithm, we, we can calculate we can calculate the uh, we can calculate the new f of x1. We can calculate the minimum or maximum value, and then we check that if k is equal to 2 and n is equal to 3. So hence, since k is not equal to n, we continue the process by taking k is equal to k plus 1. Then we get the new by in the second iteration we get k is equal to k plus 1 and k equal to 3, and again we calculate L star L star and here we get L star as 1, and we calculate the new lower bound and new upper bound. As you can see, the region has converged from 0 to 5 to 2 to 4. So the minimum or the maximum lies in the range of 2 to 4. Next we see that next this is the code in Python. Firstly, we calculate the Fibonacci numbers, and then we initialize the endpoints of the interval x1 and x2 calculation as I've mentioned earlier, and then we perform the iterations one by one, and then we calculate the result. Here, as you can see, I have got the I've done the Python code in Python, and I've got the result as 27.11, and the minimum lies at 3.33. Next, we will be discussing Fibonacci method of optimization for two variables. Earlier, we have discussed the Fibonacci method of optimization for just one variable. So, the Fibonacci method can also be used for optimization with two variables. The steps are similar to the one-dimensional case, but the search is performed along two directions. And here is an example problem. As you can see, I have taken the example problem to be x square plus 4y square minus 2xy minus 2x minus 6y plus 10 over the domain that x and y are greater than 0, and this function is a function of x and y. To apply the Fibonacci method, here we first find out the direction vectors. We can choose x direction and y direction as two vectors, and in this case I've got d1 to be 1 comma 0 and d2 to be 0 comma 1. Then we define the initial search area as rectangle with sides of length 1 centered at the origin, and then we get a1 and b1, which is for x, to be from minus 0.5 to 0.5, and a2 and b2 to be minus 0.5 to 0.5 for y. Next, the ratio of two sides of the rectangle is set to the golden ratio, which is the ratio of uh, uh, the nth Fibonacci number and the n minus first Fibonacci number. Then we apply the Fibonacci method as we know. We choose 2 points C1 and C2, C1 and D1 in the x direction, such that C1 is equal to A1 plus 1 minus R and into b1 minus a1, and d1 is equal to a1 plus 1 by r into b1 minus a1. As you can see, this is very similar to the Fibonacci method in one variable. The only difference is that instead of taking fn by fn minus 1, I have taken fn minus 1 by fn, I have taken 1 by r, and in for similarly for y, we calculate c2 and d2, and we get the values of c2 and d2, and similarly we evaluate the function at 4 points: f of c1 comma c2, f of d1 comma c2, f of c1 comma d2, and f of d1 comma d2. These are the 4 points, and I have got these values. Then we choose 2 points with lowest function values and update the search area. So as you can see, in single variable, if you take a if you take a line if you take a line, it converges from this. If this is the area, it converges. Earlier, it converged from 0 to 5 to 2 to 4. Now, in this for two variables, it has converged from a big area to a smaller area. So as you can see, we have approached, like we have minimized, like we have come closer to the minimum value, and we update a1 b1 a2 b2 c1 c2 for x and y, and we repeat the steps until a search area is sufficiently small. Until n value reaches k value, we iterate through various iterations and obtain the most minimum value. Here is the code. So if I define the function to be minimized, uh, this is the function, and then I define the search area, and I have defined the direction vectors, and then r, which is nothing but the golden ratio, which is same for all the Fibonacci numbers. Like if you even if you take f1 is to f2, or f101 is to f102, it is the same, and it is equal to the square root of 5 plus 1, the whole divided by 2. And here I have given the tolerance as 1e minus 6, and then I have defined the Fibonacci numbers f1 f2, which is the initial first two Fibonacci numbers, and then I have practiced the iterations and gotten small till the area is sufficiently small, and I've evaluated the function at 4 points. Then choose 2 points with the two lowest function values, um, two function values, and then I've realized that if I have defined that if f of c1 c2 is less than or equal to f of c1 d2, and b2 is equal to d2, and a2 becomes c2, and then I have updated the Fibonacci numbers, and then I've calculated the minimum value of the function by taking the midpoint of a1 plus b1 by 2, and a2 plus b2 by 2, and then I have obtained the minimum value of the function. And as you can see, for the above expression, which is 4x square and so on, I got the minimum value to be 6.75, and I have obtained it at 0.5 comma 0.5. So these are the applications of Fibonacci method of optimization in our stream electronics and communication. It can be used in antenna design to optimize the design of the antennas, and it can also be used in the circuit design to optimize the layout of the components, and by arranging components in Fibonacci sequence. Power consumption optimization also, we can as we have studied in VLSI, we can also optimize the power consumption, and with respect to, so that minimum power is consumed and the applications are not heated, electronic devices are not heated too much. And then we can also use it in the filter design for signal processing applications by applying the method to determine the optimal filter coefficients. Designers can achieve better frequency response and noise reduction. So, to conclude, Fibonacci method is particularly useful when the function being optimized is unimodal, and it has only, which means it has only one maximum or minimum value within search interval. It is also efficient when the function is difficult to evaluate, as it minimizes the number of function evaluations to reach the optimum. In Fibonacci method, something to be noted is that we reduce the interval and come closer and closer to the minimum value, and the values are just deleted. And also I would like to add that Fibonacci method can be used for n variables as well, but we are just repeating the one variable step several times, n times. And thank you so much.